Ja, so kyk maar wat gebeur. Die ambisie is ten minste daar.
Action!
Aan de kant dink ek is dat natuurlik dat enige eindgebruiker
dit is die doel wat ons onsself stel as 'n hoër instansie.
So I think maybe one main goal is to gradually fertilizer company. That's it.
Die boodskap moet al sterker deurkom om 'n kultuur van die regte gebruik van water te bevorder.
We have this great opportunity to host Gert as part of the ongoing SABI podcasts during 2025, a fresh approach that we started as the SABI board, speaking to well-known irrigation experts in the industry. And today, this morning of 29th of September, we have the great honor to host Gert van Der Werff. Now, Gert is a well-known individual in the irrigation world and joined various companies over the years. And currently, Gert, you are with the VKB group. Is that correct?
It's correct, Albertus.
So just give us a little bit of an introduction in terms of the representative areas, which I think is including GWK, NTK and VKB areas, but just a little bit more of the areas that they cover and the kind of environment that you get used to on a day-to-day basis.
Yes, Albertus, you are exactly right. The VKB group, as many might know, is a big agricultural company in South Africa. And a few years back, went into collaboration with the NTK group, which many of the Limpopo farmers might know as well. And quite recently, joined forces with the GWK group. So now today it's NTK, it's GWK, and VKB all in one group. And in this group, I think people that are familiar with the irrigation industry will know that it covers quite a large area of South Africa's irrigation coverage. Most will know about the Northern Cape region, following the Vaal River, the Orange River, the Modder River, the Riet River. They all join together there close to Douglas, and there's a lot of irrigation in that region. And then the Limpopo, many are familiar with the borehole sites or the boreholes, and a lot of potato farming going on. There's a lot of fruit farming going on as well, and next to the Limpopo River. So yes, it's quite a vast region and quite a large opportunity we have, but also a very large responsibility with regards to irrigation and everything regarding that.
Now, I'm glad, Gert, that you mentioned the word responsibility, because I think in essence, that is what we would like to address, is the responsibility within our industry and how we as SABI can come up with uniting individuals, end users and farmers to better understand the actual challenges and to actually facilitate the conversation. Because without the conversation, there's a lot of information that we can't share. And that's why we are in such an energetic state to share this information. And for today's topic, we would like to discuss energy costs. Now, when we talk about energy costs, many people think about particular parts of their irrigation system. So they might think about the pump, for example, and they think that if my pump has a hydraulic energy efficiency of, let's say, 85%, then my entire system is 85% effective. And that is, Gert, as we would like to unpack this conversation today, is that the truth? Maybe we should ask the question, is that the absolute truth?
Albertus, yes, that's a very hot topic these days, and it's a very hot conversation, I think. And I think there's a lot of misconceptions. There's a lot of good conception, good information available. But when I thought about this discussion that we are going to have, I realized that talking about energy and energy consumption and energy saving and everything around that, I realized that it's almost like opening a can of worms. And on the one side, it's like you're getting scared of what's going to come out of that. But then on the other end, when you look at it, it's almost like a spider's web. There are so many things interconnected into this. As you just said, just looking at the pump efficiency, that's only one part of it. There are so many things that contribute to the total efficiency of the system and the energy consumption of the system that it's almost impossible just to say, well, let's do a quick calculation and say, well, this is where I can save. There are a few very easy ways maybe to save, but that's not the full picture. There's so many things into this. So yes, I think it's going to be a very interesting conversation because, like I said, it's like a spider's web, and I think people listening to this, if they will keep that in mind during this conversation, when you work on the one aspect of it, there's just no ways you can ignore the rest of it. It's all connected together to form this web, and yes, so it's very, very interesting.
So, Gert, without any ado, let's jump into this conversation of energy costs beyond the traditional thinking of high efficiency products, where we say that if I have one component of my irrigation system that is in fact really super effective, without focusing on particular products, let's look at the bigger scheme of things. Let's look at it holistically, and let's spend a little bit time on deep diving onto the subject and understand what are the most effective ways to reduce energy consumption on irrigation farms as a holistic view.
Albertus, yes. Like I said, it's like the spider's web, and I think one very important component of any irrigation system, whether it's center pivots, whether it's a micro irrigation scheme or a drip scheme, I think the most important factor these days will definitely be to have a properly planned and designed irrigation system by someone that really have the ability and knowledge and skill to take all the factors into consideration of how to plan an energy efficient system. And we can discuss the factors, but when you look at all these things, the region where you are situated plays a role. The climate plays a role. The crop that you're going to plant plays a role. The number of hours that you have available during a day that you can irrigate plays a role. Some people might not even realize your soil characteristics play a role in this whole thing. There's so many things, and like I said, start with a good planned and designed system that take all these things into consideration. And as we carry on in this conversation, I think we will look at some of these things that influence the system. But I think a very well planned system is where everyone should start, even if it's an existing scheme or a new scheme. There are so many things that can be done these days just to replan a system to get it more efficient.
Yeah, I fully agree with that statement, Gert. But on the other hand, there's so many different irrigation designers out there and guys that provide irrigation support and services. So the question I'm always faced with is, isn't those guys the right guys that that you can approach from year to year on doing your irrigation layout, or should you be looking for particular guys? Because all these factors that you've been highlighted now, climate, the crop that you're planting, the soil, which is very important, especially when we talk about pivot irrigation, where the amount of water that you apply on specific areas becomes very important to avoid runoff and things like that, and other management practices. Is all the irrigation designers out there in a position to provide these high-end quality information, gain a survey of what is the actual challenge, and then provide a solution?
Well, Bertus, I wish I could say yes. That everyone is up to the same sort of standard. I think that's where we all aim for, and that's where we all want to go, is to say, well, we have this platform or this network of irrigation designers that are skilled enough to do this. I wish I could say it was the case, but I don't think there are many at this stage that really do this kind of design. When you look at the SABI irrigation design manual, it's a document, or it's a book of 800 plus pages, and when you look into that and you see all the factors, it's really, there's almost a field of speciality for everyone. So I think it would be very, very good to say that all irrigation designers can do all these things, but I don't think we are there yet. When you talk about soil, just the water holding capacity of the soil that you're irrigating plays a role in the amount of millimeters that you can irrigate. The amount of millimeters that you irrigate is one of the factors that determines the flow rate of your system. The climate also plays a role. So, when you start talking about these things, you need people and you need systems that can take all these things and put it together and say, okay, well, we need to irrigate this amount of water for this amount of hours in one day. And this brings us to the flow rate part of what your requirement is. Bringing weather into consideration, weather stations are becoming hot topics and things that farmers are looking into more and more these days. But are those weather stations utilized for exactly what they are there? Or there are so many things they can be used for. So yes, it would be great, but I think there's a big gap in the agricultural industry to bring, I would say, data together, where soil analysts and soil specialists share the data that they have with irrigation consultants. And these days, there's so much data available. It's a matter of sharing this data and know what to do with that data. And that's where some companies these days have programs and use, I don't want to call it artificial intelligence, but use a lot of algorithms to calculate a lot of things. And so, yes, there's a big opportunity, I think, still, and I don't think we are there yet.
Yeah, no, fully agree on that. Rihanna, you would like to contribute?
Ja, ek sou graag 'n bydrae wil lewer. Ek dink regtig dit is waar SABI 'n groot rol kan speel, sodat die boer ingelig kan word om seker te maak en ook bewus te raak van watter vrae om te vra vir sy konsultant of ontwerper. En nie net dit nie, maar ook ons het mos daarom die SABI goedgekeurde ontwerpers wat ook natuurlik kan genader word vir meer kundigheid ensovoorts. So ek dink regtig dat SABI is daar om behulpsaam te wees indien daar sekere vrae is en behoeftes is van 'n boer in die rigting van as hy sy stelsel optimaal wil laat werk en wat energiekostes ensovoorts betref.
Yeah, no, I fully agree. I can't agree more with you, Rihanna. But that just, if I can just rewind a little bit, Gert, that takes me to something that I just realized in terms of earlier conversations that we had. You actually started your irrigation career back in 1995 as a trainee officer with a then back company called FedSac. Now, if I call out the date of 1995, I'm sure that the majority of South Africa will remember that year for one big event, and that is the Springboks winning the first International Rugby World Cup, and that was against the All Blacks. I think everybody at the States remember that very historic day and date. Now, what that actually makes such a remarkable event is the fact that it unites South Africans, and that I think, Rihanna, is exactly what you say. That in essence is the aim of SABI, to unite the South African irrigation farmers by means of training, and that's exactly where your career started, Gert. So maybe you can elaborate on how important this training is and how the end user of the wider SABI community can gain from proper training.
Yes, Albertus, I think Rihanna touched on a very, very important subject in the irrigation industry these days, and that is training. And it's always been the challenge as training, and the challenge is to get the people to be interested in irrigation, and some young people to get interested in irrigation. I think SABI provides a very, very useful, very, very professional platform in the sense of training. There are very, very good courses, and from introduction up to very highly specialized courses. And I think that is very, very important. The main thing is we need more people that is really interested in this industry. Um, like we said, irrigation is just one part of the big system. There's a lot of things, and we need people that can get into it. And I think SABI provides that platform. But the other thing is, I think that what is really important is the growers out there, the farmers, need to be made aware of a platform like SABI or an institution like SABI and what is available, and what the purpose is. I think that is very, very important. Is the farmers and the users of equipment, and the guys that actually use irrigation systems, they're not always aware of a institution like SABI and what they provide, and what can be done, and what it actually stands for. So that's very important, the training part of it. And for me, when I started off as, like you said, in '95, it was a total different approach than what it is today. In those days we worked with total stations, theodolites, things that read upside down. There was no real computer programs. Model Maker and Area Maker came later on, and we started working with that, making life more easy. Then we started doing designs with GPSs, RTXs, and RTKs, and those things. These days there are all different platforms and things that can be used, and people go into ChatGPT and they ask a certain question and they get some answers and they believe it to be true. But there's so many things that can influence that. So I think SABI plays a huge role in training, and even going forward I think to justify what we are doing. And when farmers look at AI trying to do designs and things, I think SABI will provide the platform where everything needs to be confirmed and needs to stay within certain norms. I think it's very important.
Yeah, that's super well said, Gert. And I completely agree. I can't agree more. But what I would like to just go back to is when we talk about the total efficiency of an irrigation system, you have mentioned that there's a lot of different aspects that in the end contribute to the percentage of irrigation efficiency for that system that you are newly installed or planning to install on your new development. But one of the components, because it's a physical asset that you can actually see, is your pump and your motor, your electric motor and your hydraulic pump in a pump station. And I've heard it so many times that farmers focus on specific equipment and then thinking that if the efficiency on that particular part of equipment is very high, then it actually contributes to the same efficiency for the entire system. But you have just pointed out, Gert, that we have different aspects when we talk about the efficiency of an irrigation system. We look at the pressure requirement in terms of how much pressure do we need from the pump house, or actually from the water source right to the very last nozzle, to effectively distribute water. That includes the static height, friction losses, and pressure requirement from the sprinklers. Then we look at the flow rate. We need to understand how much water do we need to transport for that block of irrigation or that pivot to be sufficiently supplied with water. But then we come to the pump efficiency and the motor, and that's where I would like to just stand still for a few seconds or a minute or two. Why is it that people look at a pump and they say my pump is 85% effective, so my irrigation system is super effective? Shouldn't they be focused on, for instance, the velocity in main lines and look at the contribution of the total head requirement because of the velocity in their pipes? And if they reduce the velocity, they reduce the energy demand, and that in itself is a much bigger energy efficient contribution than only have a pump that supplies water and pressure at a specific efficiency.
Yeah, Albertus, you asked the question, why is it that people only look at, for instance, the pump and the efficiency on the pump, whether it's 75, 80%, 85 or 90%, and not look at the rest? I think the reason for that is it's easily quantifiable. It's easily, call it calculatable. I don't think that's a good English word, but it's easy to calculate what the effect is by changing from 75%, for example, to 85%. I think it's something that can be easily calculated, and that's why it's easy to use that. The same for electric motors. You know, when you go from IE1 motors to IE3 motors, it's a big buzzword. And I know there's various reasons why the drive is towards IE3 motors these days. It's also something that's easily, you can calculate it easily, and you can see the difference quite easily. But when it comes to the other thing that you mentioned, velocities in pipelines, it becomes more difficult, because now what influences the velocity in the pipeline? The velocity in the pipeline gets influenced by the flow rate that goes through that pipeline and the size of the pipeline. And there are so many things contributing to that flow rate. That flow rate that goes through that pipeline, how was that flow rate calculated? Was that flow rate just calculated by taking the area that you want to irrigate and say, I want to irrigate 10 millimeters in 24 hours, and that's my flow rate, or that gets to your flow rate? Or was there a holistic approach followed by using the correct crop factors, taking the soil characteristics into account for what the infiltration capacity of your soil is? The clay percentage, how much water can your soil hold over a certain period of time? So the moment you start, working out the flow rate that goes through that pipeline, it becomes, like I said, the spider's web that is interconnected. You cannot just only, work out a flow rate and ignoring, the crop requirement, the climate, the soil characteristics. So those are the things influencing the flow rate, and then there's always been a lot of discussion about what is the most efficient or the most suitable flow rate going through a pipeline. And it's very difficult to say. It's like asking someone how fast is he driving, and he tells you I'm driving 3,000 RPMs. You've got no idea how fast he's driving. And just working on a flow speed is, it's just part of the calculation. The number of hours that you pump, plays a role. Pumping more hours at a higher flow or a lower flow rate, or pumping less hours at a higher flow rate, which one is better? There's so many calculations that should be made. So that's why I think just using an efficiency is an easy way of calculating the effect of what it can have. But when you go into the rest, it's not an easy calculation to make, and that's why I think the focus is placed on pump efficiency, motor efficiency. Those are more easily, call it, quantifiable.
Yes, absolutely. Now, Gert, up to this point, we have addressed the topic of how can we become more energy efficient holistically. And we've said that we could be conscious about the fact that it's not only specific components within an irrigation system that contributes to the total efficiency. It includes a lot of stuff. It includes, we've said it, we've underlined it various times, the correct pipe sizing. If you have too small pipelines, you dramatically increase velocity, which contribute to friction, and friction is energy demand. So the smaller your pipelines are, the more energy you will burn from Eskom to operate this irrigation system. We understand that we need to have the correct efficiency at the nozzles, because if the water distribution, which is a result of pressure at the nozzle, is not correct, then your water distribution is ineffectively, and your C use and your D use is poor. So you could have this pivot or irrigation system running, but it doesn't achieve what it's supposed to achieve in terms of applying water on the land. We also spoke about the pump and the motor combination, which is also important. We understand that that is actually the heart of the irrigation system, but that is just actually, it's just supplying the demand. The demand on energy in terms of the flow and the pressure could be carefully designed when we look at all these factors. But one factor that we haven't touched on yet in our conversation is a hot topic, and it's actually been neglected by many farmers, and with all respect, some of the irrigation designers out there. And that is the concept of irrigation scheduling. So, Gert, you've been in the field for many years. If someone, a farmer out there, is listening to our podcast discussion today, how would you explain to him irrigation scheduling, and why is it so important?
Yeah, Albertus, once again, getting back to the spider's web. This is one leg of that web, and it's one of the more important legs of the web. Some years back, when Eskom tariffs wasn't such a big problem, water availability, water quality, all these things were not such a big problem. It was not as important to farmers to really go into irrigation scheduling. A few years back, everyone saw irrigation scheduling as a very difficult science that only the guys that provided these services understood, and farmers had difficulty understanding that. And they would just irrigate. And as Eskom rates increased, and as water availability became a bigger problem, and as these things evolved, everyone started realizing that the only way that we can keep on irrigating and even increase our irrigation areas, the only way that it will be possible is if we do better scheduling of the water that we use at the moment. And irrigation scheduling is one thing, but you touched a bit on efficiency as well. For example, in center pivots, the norm, or the accepted norm for a center pivot irrigation efficiency is 85 to 90%. We would like to see at 90%, but and now you want to start a scheduling system or a scheduling program, but your system is only 70% efficient or 60% efficient, how do you do the scheduling? Do you schedule for the 60% or for the 40%? So how do you do the scheduling? So the efficiency of systems itself, just what you can see, that's crucial, when it comes to scheduling. And these days there are so many ways of scheduling. Going to evapotranspiration models these days, it's a real big buzzword in the world. And all those systems become more and more reliable and more efficient, to use. We talked about weather stations. We talked about soil characteristics. We talked about climate. We talked about crop requirements and crop factors and phenological stages of plants and these things. And these days there are so many good evapotranspiration models available that actually make it easy for a farmer to be able to see what the irrigation requirement for his crops are. And I think by just following some irrigation scheduling method will increase efficiency a lot, and that will make a difference. I always say, just by doing some form of scheduling, I think you are a lot better off than doing nothing at all. And I think there are too many irrigation farmers these days that still don't use any method of scheduling whatsoever. And I think that's something that really needs to change. It's a mindset thing that needs to change. And I think it's a factor of the overhead cost of that, maybe. I don't know what it is. But yeah, the irrigation scheduling plays a big part. And when it comes to energy conservation and these things, when you schedule, you know what you're applying and you know what you need to apply. So you're not going to over irrigate or under irrigate or whatever. Like I said, these things are all intertwined into each other.
Yeah, no, absolutely. So, but Gert, then actually, when we talk about irrigation scheduling, I think listening to what you said, we can summarize and say that the goal of irrigation scheduling is to provide plants with the right amount of water at the right time, promoting healthy growth, increasing crop yields, and conserving water resources. That's the aim, because we only have so much water available. And Rihanna, if you recall the last podcast that we had with Mr. Felix Rangers, he shared some very interesting data, highlighting the fact that, if I remember correctly, in South Africa, we are currently irrigating, and you can correct me, Gert, if you have better data, but it seems like currently we are irrigating about 1.3 million hectares of land. That indication, bring into perspective with the amount of water available, suggests that we can only irrigate another 40,000 hectares with the water available, which is actually, if you do a quick calculation, tells you that we are actually in a position in South Africa where we only have 3% water allocation available for new developments. And that is something that I wonder how many end user farmers are actually aware of that figure. Because if we don't take these conversations to our end users and share this valuable information, they might be caught with their trousers on their knees one day, saying that I have this piece of land, but I don't have any water rights to actually irrigate this. But that's just in terms of the water availability. And the same goes for energy. I mean, we know the situation in South Africa with Eskom, the challenges we have, and the better we can become in terms of overall efficiency, whether that is irrigation scheduling or energy consumption, I think we're moving to a future where we could become more sustainable. But then, Gert, moving on to another topic in terms of our discussion, you have been worked a lot of spend a lot of your time on the ground with farmers. So what are some of the common mistakes farmers make when trying to save energy on irrigation, and how can they avoid them? Because we know, and we've seen many farmers think in a specific direction, and their fathers have done things in a specific ways. So we see that they are kind of linked to making decisions on the same principles, but that may not always be the right starting point. What are the basic mistakes that we get to see in the field?
Albertus, once again, I think it's because there's a lack of understanding of how these things really work together, that farmers tend to still go with the old ways. I think some of the mistakes that gets made is not taking all these factors into consideration. It's going back to one of your first comments, by only taking the efficiency of the pump, for example. That's an easy thing to calculate and to say, well, okay, if I can increase the efficiency of my pump by 10%, my total system is going to be 10% more energy efficient. That's not the case, and I think it's not taking all the factors into consideration, and it's because of a lack of understanding and a lack of knowledge and a lack of providing this information. I'm not sure, but I think not taking everything into consideration is one of the big mistakes farmers make, and not using expert advice. I think there's expert advice available, especially within the SABI group. There's a lot of expert advice available and a lot of good norms available. And I think by ignoring those are the mistakes that gets made, and by listening to service providers that just want to sell equipment, for example, I take VSDs. In essence, I don't have a problem with VSDs. They have a brilliant place in the market, and they have a very, very good value that they add. But not every irrigation system, is supposed to have a variable speed drive, on it, because it's not going to provide the savings that the farmer thinks. But I think that's in core. It's not taking everything into consideration, not seeing the big picture, not taking all the legs of the spider web and putting it together. I think that's some of the biggest mistakes.
Yeah. So just coming back to efficiencies, if you look at the pump's efficiency, and you can increase your pump's efficiency by, let's be reasonable and say you can increase it from 75 to 80%. That's a 5% efficiency increase on your pump. But your pump contributes to maybe 10% of the total system efficiency. So 5% of 10% is your saving. And that is a very small contribution in terms of energy efficiency. And for that reason, it's super important to look at the holistic picture, your pipe sizes, the location of your pump house, the nozzle selections, and so forth. And that is, I think, a message that a lot of farmers need to hear more frequently, that irrigation efficiency and the cost of running an irrigation system contributes out of many different components. So, but that brings me to monitoring things, Gert, and have a close eye on your asset, which is your irrigation system. So, how do you feel artificial intelligence and remote management and these kind of platforms to assist the farmer will become usable and adopted in the irrigation industry going into the future?
I think at the end of the day, Albertus, farmers will not have a choice anymore of not using some of these technologies. Artificial intelligence is a big buzzword. When you look at crop spraying these days that gets done by drones, there's a cost attached to that, but the efficiency, that comes with it, it's enormous. It's the same, by having satellite images of your center pivot, for example, where you will be able to early detect some problems that you might have on your sprinkler package, for example. So early detection gives you an opportunity to quickly fix a problem. But I also believe, that doing evaluation, constant evaluations of systems, that will become a big part as well. I see too many, especially center pivot systems, where the efficiency or the distribution efficiency of the nozzle package, has gone down from 90% to 65 and 70%. And that is just, over a period of time, these things happen. But no one, really takes that into consideration or puts in a lot of effort, to do something about this. And that is big. I think together with artificial intelligence, these things can be picked up soon, and these things can be adjusted, a lot sooner. Uh, Talking about irrigation scheduling methods, there's software available, and there's products and platforms available these days that really put into the palm of the farmer's hand, a system that is 200% better than having nothing. And whether it's 100%, I don't know. If there's a 100% solution, I'm also not sure. But anything better than nothing is 100% improvement. And I think that's important. There's a lot of things available. Talking about remote management, uh, you know, when I think about center pivots, which is the field that I work mostly in, a farmer that has 50, 20, or 30 center pivots, and he needs to, restart these systems when the ESCOM had load shedding and it restarted. Now he needs to drive on his farm. It's dangerous. There's a safety risk, and he loses a lot of irrigation hours. Um, why would remote management of your system not be something that you consider? Because that also adds to the efficiency of your irrigation. Um, so by using those type of methods, you can reduce the number of hours that you have to pump to try and catch up on your crop requirement. All these things is just, you have to use it, and you have to become aware of these things.
Now, Gert, we're talking a lot about modern technologies and the way we can use AI and remote management. But one of the more traditional ways of management skills entails that you have to get to your land on a frequently basis. And we have a lot of successful farmers in South Africa, and we know those farmers are successful because they actually get into their lands, because that's where they can see things and they can link it to errors and messages that they receive via artificial intelligence. My question would be, as someone that's sitting in the office from 8 to 5, how many of the farmers out there are actually using these available remote management platforms, in your opinion? Is this something that is out there in the future, or do we see farmers already investing in it?
Albertus, there's a lot of farmers already investing in it, and I think when you go to those farmers and you tell them, let's take away your remote monitoring system, let's take away this technology from you, he will tell you, you can take my wife, but you don't take my technology, because the efficiency that they gain, is just so big. So, but I think there's still a lot of room for improvement. We have some challenges in South Africa, but I think that's a worldwide challenge. In Africa, I think a bit more. We don't have Starlink yet available. So cell phone connection, GSM connection, sometimes is a challenge. So farmers need to invest a lot in Wi-Fi, LoRaWAN type of networks and systems to be able to communicate. And sometimes many farmers, look at the cost and they don't see the benefits. I think the main thing is for a farmer to be able to understand what the benefits of these things are, and then invest into the technology for that. But yes, I think there's a large adoption already, but I think there's a lot that still can be done to increase efficiencies in this way.
And Gert, do you think that this is only applicable to large-scale farmers, or could one say that even if you have 2 or 3 pivots, this is something that you would benefit from?
I think anyone can benefit from it. The large scale farmer obviously might benefit a bit more because the operation is big and it's becoming a challenge sometimes. But I think any irrigation farmer, whether you are big or small, I worked a bit with small scale farmers before, and by just improving efficiencies on 1 cent a pivot, and by using some irrigation scheduling method for one season, they were able to improve yields, they were able to decrease costs, they were able to save on water and energy. Um, and that's on a small scale of 1 or 2 pivots. So I think any farmer will benefit from it no matter the size of the operation.
Yeah, no, I think that's a valid point made, Gert. The investment might be small on a small scale farmer, in terms of double checking on the efficiency improvements that's available, but definitely not something that one should ignore. Then, Gert, if there's a need to understand what is the actual validity of our conversation in terms of case studies. Are there actual hard proof of case studies that we, as SABI, that you are aware of, any other companies within our industry has done to support these comments that we've been made and the suggestions that we are promoting?
Albertus, yes, case studies as such. I know of some good work that was done by the WRC and the universities, especially on energy saving and energy consumption. A guy like Professor Benny Groevier at the University of the Free State, he was in charge of a large scale work that was done, and those reports and papers are available, at the Water Research Council, and it can be downloaded easily, and all that information is there. People just need to be careful. It's very, very technical, and there's a lot of theoretical things there, but it's very practical as well. And I think there's a lot of work that has been done, to try and familiarize people with the fact that all these things work together, that it's not only one thing that gets taken into consideration. So I think there's a lot of work that has been done. I think there's a lot of platforms available for irrigation scheduling. I know of some companies, that bring the scheduling together with energy usage, and by doing that, you're able to give the end user end of season report telling him, how much water was used over a specific period of time with how much energy, what the pumping cost was, and I think that gives visibility, and that, it gives management tools to the farmer. So there are things available, and it's just a matter of combining, all the information. There's so much information available. It's a matter of bringing it all together and doing it. But there are companies, there are platforms available that can be used. Like I said, it's just a matter of bringing everything together.
Yeah, no, absolutely. Now, Gert, we're moving to the end of our conversation, and we have covered a lot of interesting topics. But before I give it over to you for the last remarks, from my side, I would say that any farmer in South Africa that's having irrigation lands under irrigation or planning for new developments, I think the conversation we're trying to facilitate and the message we're aiming to get out is for them to understand that there's a lot of different aspects that one should consider when you look at irrigation planning. So when you talk to your irrigation designer, hopefully there is something in this conversation that you have learned today and that you can ask your irrigation designer about, and for him to elaborate a little bit more on that and make sure that that is actually included in the final offering that you as the end user are paying for. But I think it's important with all the research that's already been done, if that's concerning training or product research or actual developments that's been done on the ground, that end users in South Africa and farmers should be aware of the organization called SABI, the South African Irrigation Institute of die Suid-Afrikaanse Besproeiingsinstituut, wat bereid is om inligting te deel en wat al baie van hierdie inligting en navorsing gedoen het. So on that note, Gert, I'm super excited about the new venture that SABI is taking to share this information with everybody that's interested. It's not applicable to specific listeners or specific members. Everybody is invited to take part in these conversations, and if they have questions, I'm sure that they can reach out to the SABI offices with Rihanna as the general manager. But a last word from you, irrigation users in South Africa, what should they consider to be the first and most important aspect that should be addressed with the irrigation designer when they are looking at new developments?
Well, Bertus, you want me to start the conversation right from the beginning by trying to summarize. If I was an irrigation farmer, I would make sure that I get the best advice, when I start doing my planning. It's one thing to go and do a survey on a field, measure it out, put in circles or micro blocks or irrigation blocks or whatever it might be. That's the fun part and that's always the nice part. But I think the most important thing is plan properly, get the best advice from your irrigation consultant. If the irrigation consultant cannot answer the questions, you need to reconsider the consultant. And, like we said in the beginning, there are so many things that needs to be taken into consideration. And I think even more than it was 10 years ago, we didn't even touch on Ruraflex and land rate rates on Eskom and all those things. So there's so many things. Make sure you get the best advice. Make sure the consultant understands, the process, is up to date with the latest technologies. And I think I want to agree with what you were saying. I think SABI is creating this platform for farmers to get this information. I think this will justify the purpose of SABI even more, to be able to get this information to the end users of the product. It's one thing to share this information, in the group of SABI and the designers and the engineers and all the researchers. But it's very, very important for us to get the information to the end users, the guys that need to make the decisions, the ones that need to, write out the checks and put their signatures to that, spend the money, and make the operation work. Those guys are the ones that, need to save the water, need to save the energy, need to make things work. And at the end of the day, they want a return on the investment. And I think we play a big part in that.
Yeah, absolutely. And I think when we look at the return on investment in 5 or 10 years from the development phase, hopefully one day all the farmers in South Africa can look back with a feeling of trust and confidence in an organization like SABI that actually managed successfully to unite water users in this country in the same way as the Springboks unite sport lovers in this country. And that is something that all of us can look forward to, and I'm happy to be part of it. And I would like to thank you, Gert, for your valuable conversation and inputs in this meeting today and this discussion. And Rihanna, for your friendly way of addressing inquiries at the SABI office. We also invite all farmers out there to send their inquiries, become members, and elaborate on this journey to successful water management in this country. But I thank you for your time, and I hope that soon we will catch up in the field again. Gert and Rihanna, I will see you later this week. So thanks from my side.
Thank you very much, Albertus, and thanks for the opportunity. And this is to a brilliant future in the irrigation business.
Fantastic. Thank you all. I really appreciate, and
Thank
we'll
you.
catch up later.